Hey guys, so how we're going to do this is you have to understand that this is messenger RNA here, okay? And that is opposite of the transfer RNA. And if you remember, adenine is complementary to uracil with RNA, not thymine because there's no thymine in RNA. So for here, if we look at the transfer RNA here, it has a U, and we can say, okay, U is complementary to A. So we'd put an A here. Excuse my writing using this. So then we have A here, and A is complementary to U. And so we put that there. And C, well, C is complementary to G for either RNA or DNA. Both of them have those bases. So since this doesn't matter, we're going to put G because that is complementary to C. So AUG, you have to go and you have to look up on a codon chart, and you go and you look for AUG. Where is it? AUG there, methionine. And so I'm going to go back to my paint, and I'm going to write MET, because that is the first amino acid that is coded by the codon here, okay? This right here is the codon, okay? So that's the codon, and that's what codes, not the transfer RNA code. All that does is tells the ribosome, all that does is tell basically an enzyme. Okay, this is the codon. Let me finish this. This code here on the transfer RNA tells some enzyme what amino acid to put up here. Okay, so see, there's an amino acid here. Well, there's an enzyme that reads this anticodon and puts the correct one on. The ribosome reads the messenger RNA and brings the correct transfer RNA in. So the ribosome brought in this transfer RNA, and it had the meth on it, but now that meth has been connected, is being connected up in a little factory, and the transfer RNA, since it delivered the meth, it doesn't need to be there anymore in the ribosome, so it can take off and go get another meth put on it by, the enzyme that's in charge of doing that. So here's the next one, and it's already been released, okay, just like this one was, because here's its amino acid, okay? And so here, this guy is going to be opposite here. So we're going to have G, and A goes to U. So we're going to have U here. And then we're going to have G goes to C. Okay, let me make this G a little bit better here. All right, there we go. So we need to figure out what's the amino acid. So you go to, oops, I forgot what we were looking for, CAG. Okay, so we look up CAG and we have glycine. Okay, so we go back and we put GL N for glycine. That's the kind of abbreviation for it. Sorry about this. It's kind of clumsy here. All right, so here we have tyrosine, but we don't know anything about the codon or anticodon, so we got to go over to tyrosine. And here's one, UAU. There's actually two codons for this, so let's just pick UAU for this one. Okay, so I'm going to go back here, and I'm going to put UAU because that's a codon chart. Okay, UAU. And so here it would be A, that's complementary to U, and then U, and then A again. All right. And again, oops, that's a sad looking A. All right, again, the reason this is not what is on that codon chart. This is what's on the codon chart, because that tells the ribosome what transfer RNA to bring in. This anticodon is just for some other some other enzyme out there to know, oh, okay, I'm going to put tyrosine here. That's what goes on to this transfer RNA. This will then take off because it's delivered its tyrosine. Okay, you have to think of it as a factory, and the transfer RNAs are the trucks coming in with the amino acids. And as soon as they unload their amino acid, they take off. Okay, so here we have GUU. Can we use the codon chart? No, we can't, because this is an anticodon. So we got to go C, and then U goes to A. I don't like drawing the A's on this. And A. Okay, so now we can look on the codon chart and we can see, oh, if I can remember what I just wrote, CAA, and we look over here, CAA is glycine. Okay, so we actually had glycine twice. Sometimes, they have different codons for the same amino acid, and that happens often. So there is how we do this. And this is the protein chain being made with different amino acids being put on according to the codons that are on the messenger RNA. Again, the anticodons on the transfer RNA are simply a code for another enzyme to put the correct amino acid onto the transfer RNA. And then the ribosome knows, okay, I better bring this transfer RNA in, and that's going to have the correct amino acid that then gets linked on. And then the transfer RNA will be released, and it will go and get a new amino acid according to its anticodon. So that's how we do translation, okay?